What if I told you that the next biggest AI model might already exist? Not announced, not demoed, not even named officially, but hiding in plain sight, buried inside GitHub commits, inside kernel libraries, inside memory optimizations no one was supposed to notice. While the world is busy comparing GPT and Claude, while headlines argue about benchmarks and safety debates, a different kind of AI may already be taking shape. Not incremental, not polite, not playing catch-up. Something architecturally different, something built for raw speed, memory, and scale. Some developers are calling it DeepSeek V4, and if what's emerging is real, this won't be just another model release. It will be a shockwave. Every major AI leap leaves fingerprints before it arrives. GPT-4 had infrastructure changes months early. Claude showed memory experiments long before release. Even Transformer itself leaked through research hints. And now, the same pattern is happening again. Inside DeepSeek's public repositories, developers began noticing something unusual. Not a bug fix, not a performance tweak, but parallel architectural paths, new identifiers, new execution logic, not connected to DeepSeek V3.2 running alongside it. That's not how you patch a model. That's how you replace one. And the timing? It aligns with something even bigger, a convergence of new GPU generations, new memory paradigms, new inference kernels, and a philosophy that treats AI not as a chatbot, but as a system. Let's talk about FlashMLA. On the surface, FlashMLA looks like a kernel optimization. Faster attention, lower latency, GPU-specific tuning. But here's the thing most people miss. You don't rewrite decoding kernels like this unless something new is coming. FlashMLA is built for variable length sequences, designed around paged KV caches, tuned for extreme bandwidth utilization, and optimized for future GPUs, not current ones. This is not optimize what we have. This is prepare for what's next. When infrastructure changes before the model, that usually means the model is too big, too different, or too fast for the old stack. That's a classic pre-launch move. Now let's talk about the most dangerous idea in modern AI, memory. Not context windows, not retrieval hacks, actual model-level memory. DeepSeek didn't casually release Engram. Engram is not a feature. It's a new axis of intelligence. Instead of recomputing knowledge every time, Engram allows constant time lookup, scalable recall across massive documents, separation of memory from reasoning that changes everything. GPT still recomputes. Claude still re-reasons. Even with long context, they forget by design. If DeepSeek V4 integrates Engram deeply, not as a plugin but as a core architectural component, then this isn't just better memory. It's a model that knows when to think, knows when to recall, and doesn't waste compute pretending to be smart. That's not a chatbot. That's a system with cognition layers. Another quiet signal: Blackwell GPUs. NVIDIA didn't build Blackwell for today's models. They built it for what comes next, and DeepSeek is clearly targeting it. Blackwell enables extreme mixed precision compute, sparse execution at scale, memory bandwidth that makes old bottlenecks irrelevant. If V4 is designed with Blackwell in mind, not adapted later, then it's not just faster than GPT or Claude. It's built on a different timeline. Most models adapt to hardware. The most dangerous models co-evolve with it. Here's the uncomfortable truth. GPT and Claude are still fundamentally dense models, prompt-driven, context-limited, inference-heavy. They scale by brute force. DeepSeek's direction appears different. V4 looks like it may combine sparse compute, conditional execution, memory-augmented reasoning, hardware-aware kernels, agent-first workflows. That's not a chatbot evolution. That's a paradigm shift. Instead of answer this question, it becomes understand the system, recall what matters, decide what to do. That's why comparisons to GPT or Claude may soon feel outdated. If DeepSeek V4 delivers even half of what the signals suggest, then inference costs drop, long context becomes trivial, agents become reliable, and scaling stops being linear. That's terrifying for competitors, because OpenAI and Anthropic are locked into safety constraints, product expectations, legacy architectures, public roadmaps. DeepSeek isn't. It can move quietly, release suddenly, and optimize ruthlessly. History shows that disruptors don't announce. They appear and force everyone else to react. Imagine the headline, DeepSeek releases V4, breaks inference benchmarks, redefines memory. No hype video. No staged demo, just numbers, throughput, latency, recall. The industry won't argue if it's real. They'll argue how they missed it. DeepSeek V4 may not be confirmed. The name may change. The release date may shift. But the signals are real: architectural divergence, kernel rewrites, memory innovation, hardware alignment. This is how big AI shifts begin. Not with press releases, but with engineers leaving breadcrumbs. And if V4 lands the way it looks like it might, this won't be a comparison video between GPT and Claude. This will be the moment the industry realizes the race didn't slow down, it just changed lanes.